Okay, a couple of you asked me to go over the video. So the broadcast they had. Shout out to Matt, sprinkler system guy. Matt, here you are. I'm going to point out the one point of the video where they bring up your topic of interest. Everyone else, I was going to jump around, but let's see where we go, and then maybe I'll still jump around. The introduction will be here.
Glenn Bell. I'm the associate lead for the Champlain Towers investigation, working with Judy Matrani-Reiser. And it is my privilege to work with her as well in this partnership. I also want to extend my heartfelt condolences.
Okay, here we go, guys. I let the introductions, I blew off the introductions for you.
Not advancing.
Looks like
Thank you. Thanks very much.
This is the drawing that I went over with you guys.
On to the check of the structural design. Our structural engineering project contracted with the engineering firm Cagley and Associates to check the structural design of Champlain Towers South.
So remember, Cagley and Associates are the ones eating this.
Against building codes and standards that applied at the time of original design and construction of CTS, as well as checks against current codes and standards. Now, in a separate exercise, Project 5, the geotechnical group will be checking the design of the foundations and earth retaining systems, but this deals with the superstructure. Checks against the original codes and standards will allow us to understand the extent to which any deviation...
Pause it right here, because the deviation is that the municipality, remember, they're going to protect the municipality. For their drawings I showed you guys, there's the Magician Act. Look over here at the planter boxes. Look at the planter boxes when they should be saying, hey, who approved the removal of these BMAs or beam type A's? All right, who approved those? The engineer didn't have that extent to that. He was a special inspector for the plans as they were. But as we know, they added another floor even, and for the price of admission, they got to keep the other floor of the penthouse. They removed this. They removed this. They removed the BMA or BMA, however you like to look at it. And yet NIST is saying, hey, we're going to look at the original plans and tell you this. They changed the deck from 10.6 to 11. Shit, I'm going to mess this up. 1 foot to 11.6 all the way across. That was not part of any of the plans that the town released to us. But NIST again is saying, hey, don't look at this. We want you to look at this. And here it is saying that he's going to, with this integrity that he's stating, that they're going to compare. So I call bullshit on that already.
Deviations from those requirements may have contributed to the collapse. The original code check employs the 1979 version of the South Florida Building Code, which was in effect at the time of original design and construction, and the 1977 version of ACI 318. That is a standard of the American Concrete Institute for reinforced concrete design. The current code...
So as you can see, with the pause that just went by, I have the code book from what they're referencing, 1977. I have it, and rectangular array is critical in this. Rectangular array is critical. So in here, he's not going to be talking about rectangular array per that book. He just said he's used the book, but yet there are the column offset issues. All right, the column offset issues that let me see if I got that right. Back that up. Right, here we go. So these column offset issues here is out of bounds. But yet they're not going to call that out, because if they call that out, they'll have to say, well, why wasn't it out of bounds? Why is it out of bounds? Well, initially, because there was a beam type A, or if you guys want to, that trolls me bad, or a BMA, which because they talk about stress and post-stress in the BMA stuff that I published already. You guys can troll me back, and I'll give you the link to it. Which I already published a video on that, the BMA. Just look up the channel there, and you'll see it in the previous video even. I've done it a few times, but my channel, I mean. But they're going to only show north and south, west and east stresses, not any diagonal stresses. All right, not any southwest, southeast, northeast. All these stresses are in north and south, west and east. How amazingly, it's a lie. All right, how amazing that lie is. All right, so here we go.
Be to current codes and standards. An important part of a code check exercise is to interpret the codes and their standards and using the judgment and experience of a practicing design engineer familiar with the type of construction, familiar with practices in the area of the building, and familiar with practices at the time of original construction. This is particularly important in the application of the original codes and standards because this was 40 years ago. And at that time, the original codes and standards were far less detailed and prescriptive than they are today, which allowed greater interpretation and judgment, shall I say, of the standards. Cagley Associates, the consultant who is performing this work for us, has extensive experience with the type of construction, the structural system of Champlain Towers South. They have done extensive work in South Florida, and they were quite active as a structural design firm.
Now, we're going to say prescriptive. You could say the repairs were prescriptive. The guy that did say, oh, I know how to fix this water problem. I'll give you an extra £1,000,000 worth of weight on your deck. That's how I'll fix the water problem. That's prescriptive. But this was falling under ACI until they deviated from the plans. It had supports where support should be. The spans were, the stresses and spans were okay per the loading that they required then. So they were thinking about what's prescriptive of the structure. No, they stayed on the original plans. They stayed within the guidelines. When they crossed out of it is when they left the plans by deviating from the pool deck height and removing the beam A's or beam type A, that structural load path, and leaving those columns there. The planter boxes that were added later, that was prescriptive, that extra loading that was put on this deck. That was done by, Tong Lee did the extra decking. All right, so I don't know what he's talking about prescriptive with this. I don't know where they deviated. Let me really stretch my little brain. There's some hell of a. I don't like plate slabs construction, so that's my bias. But the rebar reinforcement, if it could work with the reinforcement they had, which it did prove itself to work, could last many years without a problem. But where the problem was initially was here, because this is where they initially did repairs, the in-house management. And that was done like the first or second year or something.
Firm at the time of design and construction of CTS. So as many of you know, but may not everybody, the primary measure of compliance of a design with structural codes and standards that we're interested in is the quantitative design strength of the members and connections of the structure. In engineering terms, we speak of demand capacity ratios, which is the strength required by the loads and other effects required by the code, divided by the code-determined capacity of that design or that member.
I'm going to pause.
So a DCR of 1 or less indicates code compliance.
This is a very boring.
A DCR greater than 1 means that
Okay, so he says the graphic on the screen is lack of compliance. That means what you're looking at. Let me back that up for you. Right here, let's go there.
Of the pool deck slab to their supporting columns in a mode called punching shear. You'll see yellow and red dots at certain of the column locations. Those are indications of severe if yellow and, moderate if yellow and severe if red understrength for punching shear. The yellow and red arrows show areas of design understrength for the flexural capacity of the slab. Again, yellow indicating moderate, red indicating severe. In the most severe of these understrength areas, the strength provided by the design was only about half of that required by the original codes and standards. I'll repeat that, only about half of that required by the original codes of standards.
Okay.
For the checks of the design for current codes, the results are similar, but not.
I don't know why they're comparing against the current code. That's not relevant. That's not relevant comparing it against the current code because you fall under the code you're built on. Now remember, he has hindsight, the person, the engineering firm they hired, that this is the butterfly structure here. He continues it here, which is probably incorrect to continue that red line there because this is a continuous, this would be continuously upon the ledge of the pool, the load bearing, and now your spans here. So it's divided significantly, the load back there on that back wall, just like he doesn't have it on this wall, nor this edge of the pool. He shouldn't have it on that edge of the pool either, as that there, specifically because the expansion joint took over right there. Right here, the control joint took over, control joint. Expansion joint, I don't know if it's expansion joint or whatever, it just showed up. It's a full joint though. What's its intent? Well, they talk about it in the previous video I mentioned to you. Interesting, he does not continue his stresses into the parking area. The parking area where the cars are loading, get a pass. He's out here. But where the cars are majorly loaded, it gets a pass back here. But not over here on this one, planter box here. And this one here, which it didn't go down. So he's saying it's severe, but it didn't go down here on that side. That's where the trucks park, etc. Remember, this guy has hindsight. He has more of the photographs that we have at the time that he makes this. But specifically, he's not talking about the rectangular array as an issue that they removed. Again, the beam type A or BMA.
Identical. There are code requirements other than for strength, which Cagley checked. One example is that for some of the lower level tower columns, the amount of steel reinforcement specified for those columns exceeded the maximum limits permitted by code for the particular column size.
Now, I'm going to tell you about the maximum limit, and I'd love to do a video on that one day. I'm going to get around to it. I'll tell you, if you guys do the research, I'll do the video, I'll push it up. But there's a demo building, 1930s, that has steel in it, so much steel, it's beautiful. It's clustered like you won't believe. And it wasn't structurally going down, it was just going down because it was obsolete. Time to modernize the location. Of course, that would be Las Vegas, I'm referencing. And they put a mess of steel in there. It was mostly steel, with these columns. Just like this has a lot of steel in it. And the demo guy, the demolition crew company said, we have to use a lot more explosives. We have to do a lot more removal of concrete because the building has so much strength in it with all that extra steel. All right, you heard that? It had so much strength with all the extra steel that they had to remove a lot more concrete, special drills ordered, stuff like that, just to be able to weaken the structure, to be able to blow it out with dynamite. And then you get somebody like Bell saying that, oh, too much, and ACI, too much steel makes your structure weaker. Too much steel makes your structure weaker. All right. That full of shit. It is dependent upon your rigidity that's created with the concrete. Not just this little weak-ass percentage they come up with to make it work. It depends upon the rebar and the concrete, the rigidity you get out of it, the strength you get out of it. Now, let's just for a moment, I'll touch on, you got to realize these buildings are pretty for the most part, pretty stable until they get deflection. They're pretty stable if they don't get rocked. If all these concrete buildings don't start getting rocked, getting a world rock, swaying back and forth, without some type of joinery to allow that plate and the concrete to do that deviation.
And this resulting overcrowding of steel in that column, if you may,
So that's full of shit.
may well have
Overcrowding,
complicated
if you
and
may.
made difficult the concrete placement
Oh my
and
gosh.
consolidation of that concrete during original construction. So now I'm going to turn it over to Ken, and I will be happy to answer any questions about what I just spoke to at the end of this session.
There we go. Here you go, guys.
Ken?
Okay, are we going with the recorded version, or are we going with my audio over top of it?
We're going to go with you speaking live.
All right, very, very good. Well, good morning, everyone. My name is Ken Hover, and Scott Jones and I co-lead the material science team. An objective of the material science team is...
I think I will let you should hear this. This is about the aggregate and how they had to, source it to be able to try to make a duplicate of this material of this. Now, what's the point of making a duplicate when they can do rebar pull-out tests with the material that's there? It would also verify their sonar tests and things like that. The sonar test says, hey, you know what? There's no cracks between the concrete and the rebar. Well, film it, photograph it, document it, and cut it. Cut it very nice with the least amount of vibration with a vibration sensor on it. Just like you did there. Hey, you're exceeding vibration. Have a dampener there, whatever. You got to put it on rubber. And slice this. Slice it. Look at it, evaluate it, and say, well, it's still solid. The rebar is still solid in the concrete. So it doesn't matter what they're going to reproduce. If it's still tight against the concrete in there, that area didn't fail. So why are you trying to make up a special batch that duplicates it? It says, oh, look, this fails this way. When you have, thousands of samples that you can literally test. All right, that you can test. You don't have to try to find a certain mix and make a certain mix and batch. Besides, you're not going to be able to age it. As he's a material scientist, he's match the quarry, the plain Portland cement, all these other items, but he's not going to be able to age it 40 years. So what's your point? You're going to try to say it's the PSI. You're going to meet it at PSI. Oh, this current PSI is 4,000, so therefore, I'm just getting that from here. The current PSI is 4,000, so therefore it's going to be the same as this. I would not argue that to be true. I would say this is 4,000 40-year-old concrete. Maybe it's more brittle. Maybe it's not flexible as much.
Coated with a paste of Portland cement powder and water that initially lubricates and subsequently binds the composite as the cement, powder, and water chemically react. In any given mixture, the relative proportions of these prime ingredients significantly influence concrete's fluid and hardened properties. Detailed examination of fractured or sawn concrete surfaces, as represented by the image at the top center of the slide, yielded clues to mixture proportions, including aggregate size distributions, their geological composition and origin, and relative volumes of ingredients for the most frequently encountered concrete in the warehouse. But our ability to duplicate the original concrete has been complicated by dramatic changes since 1980 in production and availability of cement powder and the rapid evolution of chemical admixtures and supplementary cementitious materials. For example, most of the South Florida construction market has adopted the new Portland limestone cements to reduce carbon footprint. Last year, our team purchased what may have been the last ordinary Portland cement in the region, now securely stored to supply the structural tests. We also obtained aggregates from the quarry identified as the most likely 1980 source and limited admixtures to only those likely to have been used in 1980. The primary factor influencing strength and other mechanical properties of concrete is the ratio of the mass of water to the mass of cement powder. Lower water-cement ratios produce a more concentrated paste, resulting in higher strength. The University of Florida was contracted to produce and evaluate compressive strength of a set of 6 trial mixes, ranging from a low water-cement ratio of 35 pounds of water per 100 pounds of cement powder for a high-strength mix, down to a high water-cement ratio of 60 pounds of water per 100 pounds of cement powder, characteristic of low-strength concrete. The concrete fluidity or workability was controlled by fixing the coarse aggregate size, volume, and total water content. Strength was therefore controlled by varying cement content to produce the target water-to-cement ratio. Higher target strengths required higher cement content with accompanying reductions in sand content. Concrete mixture proportions are shown in the image in the lower right for 3 of the 6 trial mixtures. The measured strength of concrete specimens that were water cured for 28 days are shown in the graph at the extreme upper right. For these materials, all mixtures were sufficiently workable, and 28-day compressive strengths range from 4,000 to 8,000 pounds per square inch. Our next step is to select 1 concrete mixture for casting columns and 1 mixture for casting slabs in the full-scale structural tests. Selection will be informed by the results of ongoing compression testing of cores recently extracted from warehouse evidence. The good news is that materials that are reasonably representative of the original concrete can produce more than 8,000 psi concrete at a water-cement ratio of 0.35. It is concerning, however, that these same materials can produce 4,000 to 5,000 psi concrete, reasonable structural grade, at relatively high water-to-cement ratios in the range of 0.55 to 0.60. Regardless of strength, concrete at these high water-cement ratios would normally be expected to be readily penetrable by fresh and salt water, water vapor, oxygen, and carbon dioxide. The increase in what is known as diffusivity with increasing water-cement ratios is shown in the slightly lower graph in the upper right-hand corner. Now, back in 1980, a typical construction quality control program would have focused on compressive strength only, making it plausible that the original concrete could have complied with specified strength requirements. But typical 1980 quality control would not have been likely to include tests of water-cement ratio, diffusivity, or related transport properties that influence resistance to environmental exposure. The co-leader of our material science team, Scott Jones, will follow with that important topic. Thank you.
Hi, hello. I'm Scott Jones. I'm co-leading this project with Ken. Ken just described our efforts to formulate a concrete with mechanical properties comparable to those used in the original build.
All right, let's mechanical properties. Once again, we're talking about the concrete. This is a 40-year-old structure with concrete and steel. That steel is exactly what that steel is from 1980 to 40 years later, advanced with calcium chloride issues and etc. with stresses on them applied over 40 years. How are they going to do that? How are they going to put rebar? Are they going to sacrifice some of this rebar in their design mix and then do their stressing? Well, it won't matter. It's all fake because it doesn't behave that way. No column failed under compression like that. All right, it caused the collapse of the structure. It wasn't column compression failure. This is simply out here in the deck with the spans, and they're doing smoke and mirrors, blowing smoke up everybody's ass. Smoke and mirrors, ass blowers here. Here we go.
Building. That effort led to the important finding that the materials used to create concrete for Champlain Towers South is capable of meeting specified strengths, but with water to cement ratios that suggest the concrete may lack sufficient durability properties. Our invasive testing plan is focused on obtaining data necessary to explore the durability and mechanical properties of the concrete and steel used in Champlain Towers.
They're throwing the architect and the engineer under the bus, all right? they do need to be thrown in a bus along with the municipality for allowing the deviation of the loads, of the load paths. All right, to allow the offset columns. They're saying, look over here, look over here. We want to talk to you about the Portland cement. We want to talk to you about the Portland cement. You know what we want to talk about? We want to talk to you about the Portland cement. Talk to us about the offset columns. Talk to us about the missing structural steel beams that were supposed to be in there. Talk to us about why the plans talk about pre-stressed concrete, and where is that? Talk to us about why there are no plans that show the change plans of the elevated deck change. But they does show the change plans. They do have changed plans of the tower, of the penthouse. They do have changed plans of that, but not of the pool deck design. So, you know what? I can't take it, guys. These people are full of shit, and you guys, I'll give you the link here. You come over here and torture yourself. I can't do it. It's like, being trolled. I'm being trolled hard with this lying BS, smoke and mirrors. Look at the Portland cement. Look at the cement. Look at the cement. Bullshit lies. We should be looking at this municipality allowing the deviation, starting with them allowing the plans to go through, knowing that they would need to upgrade the water system, the sewage system, and knowing they were going to come back and hit the owner for $200K on the back door after he got started. That was some extortionist shit, saying, we're not going to do it, but yet they then make it look like, they bribed the municipality, let people believe that the engineer and contractor bribed the municipality to do that. No, they fit the bill for half the damn sewer upgrade for the area.
Don?
Now, here's your questions, guys.
I'd like to just get a little more clarification on something that Glenn Bell said early on about the apparent overload or high demand capacity ratios based on the design.
Yeah.
I think for clarity and to keep things in perspective, it might be useful to reiterate whether that's according to the original code or the current code, because one might say the current code is a better understanding. And also what loading cases, because we know that the design loads were not on the structure at the time of the failure. Is this wind? Is this gravity? That kind of thing. And to the extent it's the current code, to the extent there's a difference between the codes, is it because of changes of loads that we assume in design or changes in strength that we assume in design? It's a multi-part question, Glenn. But I think clarity is clear. You made it a point to reinforce that observation. I think we need to have clarity on what it means.
Absolutely, and I'll do my best to answer the questions that I recollect, and if I miss some, and when I miss some, please ask me again.
Called out on it.
First of all, this is a design check, right? And we used both original code and standard conditions, and we used standards and codes that would apply today. Two sets of analyses there. In the graphic that I showed you, that was the original design check. The differences from the current code check were a little bit different, but not dramatically so. In terms of overall impression and conclusion, they were very similar. There are some differences. The primary differences, particularly in ACI 318, are with adjustments in load factors and fee factors or resistance factors. And that can change things a little bit. In terms of loading conditions, they are the load combinations that are required by the codes at the time, and currently, depending on which we're studying at the time. The primary control
load requirement at the time. Again, offsets was wrong. So he's being deceptive by not talking about clearly what we know is that the 21st video, June 21st image presented to us, is that this is a major indicator of the beginning of the failure. And why? Because it didn't have the beam in there, it was offset. This was Supposed to be a drop slab detail. Please.
Controlling load cases for this pool deck slab are gravity loads. So it's primarily dead load plus live load. Something that's very significant in this analysis is that the live load for the pool deck slab is 100 psf, which is pretty high for its use, and it's unlikely that the structure experienced that load with any regularity, if at all, over its lifetime. And we think that the live load at the time of the failure was quite low. But we weren't representing in this analysis. I'm going to talk about a different analysis later today, but in this analysis, we weren't looking at pre-collapse conditions. We were doing a code check. What did I forget to answer?
Nothing, I'm fine.
Okay.
Did you go ahead? Pepe, then Gary, then Bill.
I have a question for Ken. Ken, and in all the varieties of factors that you explored, did you guys check the size of the cement particles from when the building was built and the regular size nowadays in Florida?
Well, that was a bit of a problem, and that was one of the reasons that we worked very hard to try to acquire some ordinary type 1-2 cement, recognizing that if we bought off the market the 1Ls right now, we would end up with a much finer overall particle size. And then, of course, after 40 years, it would be very difficult to microscopically go back and try and figure out what the original cement grading would be. So, first of all, we were aware of the importance of what you just raised, and that's why the best thing that we thought we could do was to acquire an ordinary Portland cement rather than a current type L modified. Point well taken.
Thank you.
Yep.
So thank you for updating your significant work on various analyses, and I do like the separation between the code check, right? And you talked about that, and just to be clear, that's based on the code, at least in one case, the code at the time of the design specified material strength, specified conditions, and then you have other analyses, the Athena analyses and so on, which are targeted towards conditions at the time of collapse. Do I have that? With respect to the code check, there may be some, you showed that there was an overlay on top of the pool deck, on top of which the original tile was placed. Before they put more waterproofing, more sand, and more tile. Was it presupposed that even though that overlay may not have been shown on the drawings, that the structural engineer knew about that and or should have known about that, and that was considered in the dead load?
That's a great question. So there actually were more than one opportunities for overlays, and we saw, as Jonathan has described, overlays on top of overlays. You're correct that the original design drawings did not show an overlay or a topping on the original construction, but the plumbing drawings show that there would be slope to drain. And so our design interpretation was that there would be a sloped overlay to provide that slope to drain, and we included the dead load in that portion in the original design checks. We did make a subsequent design check, and I didn't go into that for the loads that were added subsequent to the design or in addition to those that were on the design drawings. But we did include an overlay that accounted for the drainage that was shown on the plumbing drawings.
Okay, thank you.
Okay, so what he's referencing is the pool deck. Imagine it being flat, all right? But then they had drains, surface drains, and it says slope to drain, okay? So the pipe is sloped to drain, or he's doing assumption that that there's an overlay added looking at top view, this is a drain. There's an overlay added, and the overlay over top of the flat structural slab would be your slope to drain. Tong Li never speaks of removing an overlay slope to drain material getting to the structural deck. With that said, we do see that Tong Li did some slope to drain concrete. All right, in the drawings, as I recall.
Okay, thank you. And so then you focus your attention on the loads at the time of the collapse, and at least in my opinion, that there needs to be kind of a clear separation of those, right? And
We've been very particular about that, yes.
And the second is challenging. I know you're working on these things, and you mentioned all the various conditions, and we're measuring concrete strengths now, and we've even had conversations about some of the challenges relative to the moisture content and so on of the concrete. But one thing that wasn't mentioned, but I think I brought up before, is time-dependent effects.
Yes.
And we know that concrete under sustained load is weaker than concrete under short-term loading. And you know, the pool deck had a sustained load for 40 years, right? So maybe for everybody's benefit, talk a little bit about how you're going to consider time-dependent effects in the collapse scenario.
So far, we're working with that in the literature, understanding time dependency. There isn't as much there as I think any of us would like to see, so we're doing a broad study of...
So you can't make a sample duplicating the time. All right? You can make a sample duplicating the failure. Just make some broken-ass concrete and say, there we go. Looks like that's the broken-ass concrete. But you're not going to be able to duplicate the time. The swelling, the expansion, the contraction, the movement, because there is the solid concrete is not what's really failing here. What's failing is the grip strength of the rebar and the concrete, not the concrete failing, but the two of them together no longer staying bond. You know what? These are just a bunch of
what there is in the available literacy. We've done quite a bit of study of creep effects, and as you know, creep and time dependency are sort of cousins, if you will, so we're using that as well. And we're going to factor all of this into our progressive collapse analyses or interpretation or modification of the strengths when we get in deeper into the progressive collapse modeling.
And just quickly, of course, time-dependent effects, to the extent there is literature, it's mostly on the compressive strength. And we think these are punching shear failures, which is a little bit more of a tension/shear phenomenon. If you go to the trouble to replicate these mixes, is there any consideration of moderately long-term loads on tensile specimens to understand potential degradation of tensile strength over time using a mixed design like this?
Others on my team can add to this. Fahim, do you want to take that?
Yeah,
I mean, be your model.
That's not a consideration at the moment, but maybe we need, in the structures team, we will need to huddle and try to see if we can address that. But it's not included in the experimental program. Jack, am I speaking correctly?
That's correct. We've also worked with an expert.
I remember you can't, the audio sucks. There we go.
The diagram of the code check showing these understrengths, significant and less significant, so on, are those understrengths considering the live load combinations, or is that, dead load overstrength, or under what loading conditions are those done?
Those are strictly the demand capacity ratios that come out of a code check.
So that would include live load then?
Includes live load, all of the relevant load factors and load combinations in the codes, and of course determining capacities in accordance with the rules that, for example, 318 prescribe. Yes.
I have another question on the analysis. You were suggesting you were doing parametric studies. I was just wondering what were you varying, and have you seen huge changes in results based upon some of the changes of assumptions?
Yeah, I mean, one of the information that we collected from the warehouse, for example, was the fact that the top rebars in the pool deck slab were lower than where they should have been, and that definitely have a significant effect on the punching shear resistance and also the flexural resistance of the slab. Boundary conditions also for these nonlinear models affect the response to a large degree, given that, for example, the constraint on the south perimeter wall, if you consider this as allowed to move laterally or prevented from moving laterally, this would tend to either generate large amount of compression forces in the slab, which in turn would affect the punching capacity. If you keep it, allow the motion there to be allowed, then you get larger capacity because there is not, so you get smaller capacity because...
Remember I talked about expansion joints inside this whole thing. Where are the expansion joints? That's basically what they're talking about. Interesting, they're not talking about the vibrations from the other wall. In fact, in their drawings, they leave out that wall, don't they?
The compressive force is not south motion of the slab at the perimeter wall. One, we allow that as a roller, as if there is a roller support there, and one using the springs that Yosef and Sisi developed for us. And you definitely can see significant effect on the deformations of the slab and on the punching capacity of the column, especially on line 15, just to the north. The reason for that is is a phenomenon that would occur in the vicinity of the columns called slab dilation, where the slab tends to expand due to the rotation and also due to the cracking that takes place there. And that would tend to push the slab outward. So when you prevent that motion, that induces larger compressive forces. However, what we see is if you leave the that perimeter
expansion is an issue. Contraction.
Open for motion in the north-south direction, you see initially that when you apply loads on the slab, that the slab would push outward, meaning
look, guys,
in the south direction here and that.
I can't take being gaslit. All right, this is gaslighting again. They're saying look everywhere. Look, how about expansion and contraction, which I talked about with you guys. Again, how about the original drawings? The original drawings that they deviated from. The design, the structure, how it was by the steps, how it was going to be supported. 1 foot elevations change. Over here, 1 foot elevation change. Everything that leads to that offset column, which you're not going to get from these guys. So I'll give you the link to the video. I can't take this shit anymore. So I'll bring you to this one. This is the conclusive, right? Yeah, not really. They still are magically in the dark all these years. All that brains up there, experts, just all blowing smoke up your ass. Here we go.
About the cause or causes for the failure.
We have not reached the finding.
Either in the initiation or the progression. We're still exploring that 24 failure hypotheses, roughly, with a number of potential causes and contributors. But I am here to report that our analysis to date shows that even absent any sudden load or sudden overload or obvious initiator of a failure on that tragic night of the collapse, the conditions that existed in the pool deck slab at that time represented a serious safety concern for the building. When we design building structures, we design them to have margins of safety.
Okay, so I want to bring you to what he's calling his low margin of safety. First, he said it was a zero, means that it's collapsing. No, zero means you've got no margin, no your factor, your whatever it is, your load is if you design it to take 1,000 pounds, that's it. You got no fluff over that. 900 is good. 999 is good. 1001, and you're over. You're over what you calculate what your loads to be. He said it's an imminent collapse. So I don't know what the hell he's coming up with that version of zero margin. Negative would be imminent collapse, and with the load that you're talking about, which he doesn't tell us. But
margins. The first factor illustrated here were deficiencies in the original structural design of the CTS pool deck slab.
It's not
I
the
presented
original.
this in theme 2 earlier, and I mentioned that the design check showed that the original structural design of the slabs and slab to column connections in the pool deck fell well short of the applicable building code. So from the beginning, the original structural design provided low margins of safety.
Now it's Marcia. So
the second factor...
he's lying to you guys. That drawing is not the original drawing. We know that, right? It is elevation change. So he's showing you that, saying it's the original drawing, and that one doesn't have the pool in it either. He's lying, all right? It's a clear, just lie. I don't have to say anything else. Don't worry about any deformation. It's a fucking lie. Original drawing, that is not the original drawing.
Reducing the margin against failure was improper replacement of the steel reinforcement in the pool deck slab during original construction. Our measurements, and Jonathan and Chris and others showed summaries of those. Of the pool deck slab specimens that we have stored in the warehouses show that typically the reinforcement in the top of the pool deck slab was placed lower than was required by the design documents. More specifically, the design documents show that the top of the top layer of that reinforcement was to be placed 3/4 of an inch down from the top surface of the slab. Our measurements show that it was typically and very commonly located about 2 inches down. Now, the placement of this top reinforcement in a flat plate structure is really critical. In pool deck, that misplacement in the original construction.
Let's be clear. Top steel, it was his temperature, was part of his temperature steel, but also for the expansion contraction, but for that I talked about. But also, it's the cantilever steel. I call it the negative steel. It's the steel for negative loading. Your deflective loading is your steel at the bottom. So for him to bitch about this, he's bitching about the top steel. And he's showing an image where they cut it, and we don't. In this image, there's no breaks. So you're bitching about it, and it's the wrong piece. You should be bringing us the piece, the sections that actually failed over there with the rebar, and then you'll show that grip force failed, not this because of this. And besides, we have 40 years of this structure behaving under this loading. But it was brought to a critical position, critical notification with the engineer that did the inspection, that most of the deck needs to be replaced. They're saying, look here, look here, look here. Remember, it's the column offset. It's that one. It is the one that they took the photograph. It is that one. They're going to bring it up. So remember, psychology-wise, the truth will always come out. Because we just can't lie. We always tell the truth, whether it be a little joke at the end, a little laugh, or whatever it may be. The truth will always reveal itself. This is smoke and mirror shit that they're running here.
Construction significantly reduces the margin of safety.
And let's be clear. If they wanted to tell us the truth about what's the difference between 3/4 inch and 2 inches... all right, they would have to first, because this deck is so fucking erratic. It's got steel in so many different places, 12 number 4s here, 16 number 4s to butt the 12 number 4s. How's that possible? It cannot happen. It's got a lot of funkiness going on there. We have the butterfly area failure, which is shown that's probably what stressed this column. It was stressed because of the column offset. The one we talk about. If you really want to know how this behaves, well, I can tell you that it didn't fracture. that there is no fracture, right? Short of maybe they moved some things. This is still together, even though they cut it and dragged it and lifted up by a crane, drove it fucking a million miles across the world, basically, drove it again, transported it again. It's still together. That it fell down onto the ground, if this is one of the pieces that fell to the ground. Everything else. And look at it. And so you're going to now tell me, oh, here's the problem here. This is the close proximity. Well, I'm looking at a sample that's still together. Then you tell me, well, we got to make a sample up. Because, we need to make a sample up that fails, basically, because this shit's not failing. Because we can see it's not failing. Or their brain just doesn't have the capacity to understand exactly what they're fucking looking at. You take your pick, either they're being deceptive or their brain is just weak. Very weak. Because you can tell me this all you want, but I don't see the failure there. I don't see the separation of that steel and that concrete from there. I see a rigid pad. Yeah, I see some fractures that possibly happen because of all your movement and vibration and bouncing around. But I still see they're pretty tight, although they did not reveal the depth of that with the sonnet test. They didn't say, this sample, we show that fracture goes back so deep. Even if it did, I still see this measurement and this measurement close together, although I know that they've been using forklifts on it. Look on it. They've been pounding at this damn thing. So who caused this destructive behavior? They did.
Particularly in the punching shear
And I showed you them destroying it, throwing away steel.
The third factor involved heavy materials that were added to the pool deck, and Jonathan spoke in some detail
And that
about
would be
this.
tong lead.
Our knowledge
not,
of the loading of the slab at the time of failure
not this.
comes from our review of the condominium association records, review of images of different types, and our interviews, lots of sources. This slide shows that a line of added landscape planters near where the pool deck joins the building's tower, up near the north side.
All right, this is when I gave you the short version of
the
it.
Pool deck.
This is where I gave you the short version of it when I was doing over the slides for you guys. And I can't listen to this guy again. That this is all a lie. That looking at this is a lie. Saying, look over here. This is a magician act. Look over here, and look at this. Look, they put the rebar in a different place, but don't pay attention that the concrete's still together. Ignore that part. All right. They want you. Oh, look at the palm trees. Oh yeah. Look at the palm trees. This is ridiculous. Next thing you know, they should start in the main building. They should start talking about the marble like Tool Time did. Jeff likes talking about the marble. But Jeff can't read the fucking plans because in the plans it says put marble inside the bathroom. Yeah, I never bothered trolling back with that, but I'm telling you now, the plans state marble goes in the bathroom, etc. So, you know what? Clown show. So this is a clown show here, is what they're doing here. What's critical is that the punching shear that was observed, the deflection was there at the time of failure. Let me fast forward the screen. Let me see if I can get you the one. I had the thumbnail images. No, let's listen.
In the middle image, one of the columns, and this picture was taken by one of our NIST engineers at the building site shortly after the collapse. And it shows one of the tops of one of the columns that once supported the pool deck slab. Yeah. If you look at the enlargement on the left here, you can see that there are 4 hooked reinforcing bars that emanate from the top of the column into the pool deck. That image on the right shows the same specimen. We have it now, that same column in the warehouse. And you can see in the left-hand image here, and those of you who are close, maybe not those of you who are farther back, there is a marked degree of corrosion on those hook bars in the images. So we are exploring all these specimens and the images to see what we can infer about the corrosion of those hook bars in the tops of the columns and how that relates to the reinforcing of interest in the top slab, because those hook bars were very close to the horizontal top bars in the slab specimens. As Fahim described earlier, we will perform load tests on full-scale replicas of different parts of the CTS structure. Some places not so deep enough. Background material, managing the teaching for us.
Comments from individual presentations, but now that Glenn has summarized it, let's open the floor for comments from the
There we go, and I'll let this ride. I'll give my last rant one more time.
Gary.
It's only 11 minutes
Again,
left.
I apologize, but again, it's my last meeting.
Sure.
You talked about the trigger or lack thereof.
Yes.
And I don't think you should find that terribly concerning. In steel failures, like the Hyatt, there was somewhat of a trigger and there was more live load than it's ever seen. Same thing with I-35W. But we've seen concrete structures, and probably you have as well, that fail on a sunny day with no obvious trigger. And the same is true of timber structures. And the commonality is that there's a time-dependent component, right?
Yes.
There's an accumulation of damages with models is what they use in the timber industry. Maybe not so much in concrete. So, I don't find that terribly troubling that we're not able to find an obvious
Okay,
trigger.
so he meets the...
May I respond to that, or you're done with that question? Yeah, we agree 100%. I mentioned triggers for two reasons. One is we're asked about it a lot because everyone thinks that something must have happened on June 24th to make this happen, and we're still looking for that. We have to make sure we haven't missed anything.
The failure was indicated.
But our experience, my experience from
building,
investigating failures for a long time has been that these happen sometime.
You know what? I'm giving a shout out to Dawn Lehman's lady, the lady from the news, the Miami Herald. I forget her name. All right. So I know I beat them up on their Emmy, on their hand them in the Emmy because of all their defective thinking. But if this is the version that NIST is giving, the Miami Herald, Dawn Lehman's version is much more plausible than their crap that they're sticking up. They're just shoveling now. I mean, they're just throwing it. This is just ridiculous. So I just want you to tell you that. Now, with that said, her investigator had the guy that okay, my brain's freezing. I paid for it. I paid for the audio. The guy that does the walk around for the building, the maintenance guy, whatever you want to call him, the property manager, he did the walk around. He noticed it many days before the crack there. He called the engineer. The engineer came out the day that they were going to inspect the roof, not specifically for that, but they were inspecting the roof. Those safety clips. My brain's frozen on that. So he wasn't really jumping for that. Remember, that's the root guy calling out for the roots. So you're looking at their inspection, Dawn Lehman's girl. I don't remember her name. Well, I'd say it, so I'm just saying it's Dawn Lehman's girl, the Miami Herald lady. That she did the better investigation with that guy, saying, "Look, I called it." They're making it seem like it's just the 21st that the image popped up. All right, no, and fuck no. The guy reported that days before to the engineering firm that the crack, and they're hiding that. The offsets this offset is all me. I think I'm the only one talking about the offsets per ACI. They're talking about they were going over ACI. We'll talk about that the offset problem is critical here in the deck. No, we can't see that. We can't see that because that might point back to the municipality should have caught that and never approved it. No, we're going to point at concrete, planter boxes, and palm trees, and pixie dust. All right, we're not going to do that. We're going to prove this planter boxes because we had only the 21st. It just popped out of nowhere, that crack. That's what we're sticking with. Not that in 1980, when the damn building was built, they were already doing structural repairs of epoxy, incorrectly, I might add, on the other side like that. You just locked it open. You didn't fix anything. That bond strength does not work. For all you engineers out there that are specifying that you have a crack pad, let's use a crack pad like this. This is the crack here. All of you engineers are specifying epoxy here to help take care of this deflective load going here. You're wrong, all right? I've tested it numerous times. I've got a video on it. Call me out on it. I'll give you a link to it. Tell me what epoxy you want me to test. Send me the little bit of money for the epoxy only. I will do the test for free for you. I'll get some concrete, some aged concrete that I get access to, tons of it. I'll crack it however you want me to crack it. You want me to crack it with overloading? I'll epoxy it. You tell me. I'll prep it. I'll do a big production of it. All for free. You pay for the epoxy. Don't be cheap. You pay for the epoxy. I'll get the aged concrete. I'll epoxy it together. I'll do a live video, not a live video, a video showing that I'm not doing these magic act. I'll do the proper prep work that you and I will agree to. And we'll put the epoxy in there. If you want me to sit on that epoxy for a month, well, then we're no longer in, it doesn't make sense to test a month later. It's going to be loaded sooner than that. But if you want me to sit on it for a week, for some reason you're able to keep people off the bearing area for a week for whatever reason, I have no idea why you'd want that cure time. But if you want that cure time because you say, in our temperature, the cure time takes a week, I'll give you a week. If you want me to put it in do the repair and put it in a humid controlled area, I'll do my best. But I can do it inside a garage. I can do it inside a shed. I can do it out in the sun that's baking. I can do it at a lot of places for you to if you can tell me what you need to duplicate. I can do that. But duplicating Florida, I can't do unless you put me down in Florida. You pay for the trip. You pay for the gas. And I'll still do it. I've got plenty of places to stay in Florida. So if you want to do it down there. But this does not work, all right? What does work, I say, look at my videos. I call them staples. That does work to lock it in. This little staple idea, it does work. I'm putting steel across the bottom and securing it with epoxy. That does work. It has its limits, of course. Everything has limits. But that's another thing that works. But just for epoxy here, that doesn't work. And that's what they did in 1980 something by the building manager. That's critical because that's there. It looks like I'm extrapolating. It looks like it's down that zone. We have the garage walkthrough. The garage walkthrough shows all those fractures coming to the column area, which implies that we have sagging in multiple places. But yet Bell here can't put that together. His whole team. Palm trees. Those planter boxes. Yeah, that's it. Oh, and they put the rebar down a little bit, touch lower. Yeah, but not the walkthrough video that everybody else can extrapolate that there's issue of. Not this team, not them, not these $23 million fucking dollars worth of money, right? $23 million. Not these people. They can't do that. They still haven't made a sample up that they can come up with. Now, who's being jerked off here, right? We're being jerked off, and not in a positive way. I guess it can be, that's sexual. Sexual is kind of positive for me. It's just, I don't have a negative to it, but you get, the negative version of it when I say it. We're being okay. I don't even know what the term really means when you're trying to say it negatively. What does that mean? I have a few jokes I could say with that, but we're being screwed. How about that? Wow, we're being screwed and we don't want to be screwed. All right, we're being screwed and we don't want to be screwed. And these are the people doing the screwing. The government. The government are the people doing the screwing. They're the one laying pipe on us. They're all dickheads, right? The government. So I just can't take the deception. what is her name? Sarah something. Sarah Blakely. Is that right? Sarah Blakely. My brain just hit me. Is Sarah Blakely? She's doing a better job than Clown Show. And you know I beat up on Sarah Blakely and also Professor Lehman. But I stopped beating her up when she commented, came there and chatted with me. I told you that I don't do. If you want to banter, I'll change my attitude, and I've changed my attitude since I've blocked my videos that may have been talking negative, besides the ones that she communicated with. And I offered to her, if you want me to delete something in here, I will delete it. She passed for that and let it ride. She's got tough skin, she said. Good for her. Not, I mean, it wouldn't have hurt me to say it, and I wouldn't have publicly let it be known. I'll still offer that to you. I'll make it disappear if you want. But he is a shill for lies. All right, for them. Sarah Blakely got down to that. It's not just the 21st. It's the smoking gun area. The engineer's report talks about the smoking gun problems. Not them. We can't figure out the trigger. Time dependent. Yeah, we can't figure it out. We're gonna need another $50 million. We need another 2 years. Incidentally, I said 3 years in a couple of videos ago. Shit, that was 2019 June, wasn't it? This is 2023 June. That's 4 years. I'm lost in translation. Right? Wasn't that 2019 that thing went down? I'm confused myself now. So it's been so long, so many years flicked by because we locked our asses up. All right, and I'm a constitutionalist. For all you people to think I believe in left and right and all that, both of them are they're both together, right? They're both fake. They're both being lobbied. I'm a constitutionalist, so just so you know, I believe whoever believes in the Constitution, whether you're a Democrat, Republican, Independent, whatever, if you believe that the Constitution is the one that's superior over all the other crap, then I believe in that. So if you believe that you have a right to privacy and all the other stuff, then that's what I believe. All right, and you've got some God-given rights, as they state, meaning that you have a right to eat, a right to free roam, etc., which we don't. I'm going to tell you that this government is full of shit. This is gaslighting, all right? This is what this is. If you do this and you push their narrative, you're pushing the gaslighting narrative, all right? I give a shout out to Professor Lehman, right? And I always mess it up. I said, Don L. Lehman. What do I mess up? Don E. Lehman. It's E, I think. And I'd say Don L. I double down on this part. And then Sarah Blakely. All right, so here it is. I told you I'm always willing to change direction. Sarah Blakely, and yes, I said they gave them they're wrong in a lot of their assumptions and their calculations, and they're getting to where they're getting to. But they're more right than Clown Show here. So, this is ridiculous. And now we're going to have Papa Smurf come forward. And I don't think Papa Smurf, I call him Papa Smurf in a nice way, guys. That helps me memorize him. Yeah, he's going after the money and everything else. All right, so be that. But Papa Smurf, I bet you, will come up with a better conclusion than these clowns. Nist is a clown show. It's been a clown show for years. They're still a clown show when it comes down to investigating. It's like asking the cops to investigate their own killing, their own shootings. We already know that. They have it justified. All right, they work for the government. They're going to protect the government, whatever government, all the way down the pipe. Again, because they don't do the offsets. I would challenge Sarah Blakely and Professor Lehman to tell me that I am wrong, based on now this release from them saying that they're looking at the architectural drawings and basing it on ACI, the book I just showed. The that they're shopping the drawings, that they're saying, we're going to use this drawing as the one representing them. That's the drawing I told you they slipped in, because if you see the notes, they said in the notes in that one of those drawings, it said change of something. And I did a video on that. It said change. Look at the notes on that drawing, Professor Lehman and Sarah Blakely. Look at the notes of that drawing to the far right, one of them where it's like a January or March updated drawing of when they did the changeover. It on the notes it says change of something. I did a video on it. Maybe it was adding the hot tub, or it said change of something very small. But it was a trickery thing. All right. Now it's something. It was a trickery because then the city goes, oh yeah, they see the notes. You only make them look over here. Look here. Don't look over here. So they look at it and go, okay, we see what you changed. Okay, we agree. And these are the plans we approve for the next level. Haha. But not knowing what they also took out was change of the BMA. The BMA is missing. Multiple BMAs are missing. The elevation of the deck changed. Also, where the over there to the right, where they call it, everyone calls the H-beam, which is really more developed than that. Also, the change of that kitchen area is bumped from 4 feet to 5 feet. All right. So, Papa Smurf, if you catch on to this, so look at that also, and well, that would be Don Lehman and Sarah Blakely and them. But don't believe there's smoke and mirrors here. So with that said, I gave them a shout out. If Sarah Blakely strokes their ego and says, oh, they've got this now, then Sarah Blakely just sold out. All right, she's going against her good knowledge that she has. And if Professor Lehman does it, then she's going against her good knowledge also of what she knows with the which may be new knowledge. Keep in mind that Professor Lehman did reveal to us, us publicly talking to me about that. Look, some of that stuff that Sarah Blakely put was not all hers. So I was incorrect to keep saying it was Professor Lehman stating it clearly. When in reality, she told me that it was a cooperation, and some of it collaboration, and some of it was might not all have been her position. So that's the out on that. Again, the BMA, the column offsets is critical here, and there's more in the deck level change. And remember the notes where it says, maybe I should get that. So here are the original plans with what I just said, the BMAs right here. Tolerate me calling them BMAs. If you want to call them BMA type A, you just ignore that then. That's a specific measurement. Just ignore it and just call it your beam type A if you must. All right, so that is the elevation change from 1110 to 1110, 1010 to 1110. That elevation changed there. If you go find those other notes, you'll see that when they changed this, that they put a little note over here, like that's what they were asking the municipality to update something very small over here. In reality, they removed this and they changed. Where's my 4 foot? Son of a bitch. Over here. They changed this from 4 feet to 5 feet, right here. That got larger. That changed the dynamics over there, nevertheless. And they never revealed to us the expansion joints or whatever. And remember, this was 2'6", and that drops to 1'6". And then we have, with that said, we have the offset, right? And the engineer and architect knew in their drawing the offset existed 100%, because when they changed it and submitted it to the municipality, they show how much of an offset it is. Sorry, this was a model I used. If you guys remembered, I had glue sticks in it. So you're looking at when I removed the glue sticks. And I didn't print another one because I wanted to use this one. And when they did that, this had still a critical shear zone with reinforcement on it. And when they removed this drop detail, sorry about that. When they removed that drop detail, that created the this whole dynamic that ironically lasted 40 years. So for you people looking for it, just look up this public meeting right here. Just Google it. Okay. And sign in if you want to, and they'll send you when they update, they'll send you all their updates in an email. You might also find it under this. You might also find it under here, and you'll get this more data there. A couple of you asked me to give you it, so there you go. Least not forget Tong Li, as this document is called. This is also the people concrete chiller support. That was the roof repair, but Tong Li did the structural deck repair. So don't forget that he loaded this deck. All right, he loaded this deck and made it unobservable. Some cracks that would be on the top side. It might be like a column bending down, but this would not be observable. And again, the planter box, the inspection was never to remove roots, and let's take a look at it. It was the tile that hit it on the outside, and it wasn't observable, and in the inside, he didn't ask for exploratory. That inspector, he did not ask for an exploratory down to the pool deck, structural slab. So right here, this is what I'm talking about. See, look at this. Revision, January 17th, 1982. Change of column type. That's what they wrote there. But in reality, she says change of column type. I keep that in mind. Let's see, I gotta get it right. All right, that's a revision. Change of column type. And I don't know specifically which one it is, but revision, change of column type. That's it. But all of a sudden now we're missing the BMA. It's gone. The BMA is gone. And if you zoom in, let it load. You're now at, I said 5 foot. You're now at 5'8" on the kitchen. They bumped that out. But the smoke and mirror trick was they said, hey, we just got one revision we'd like to hand to you. It's change of column type. In reality, it's also removal of the BMA, bump out of the kitchen is what I've been able to observe, in that part. And changing of the steel over here when they removed the BMA by adding a couple of pieces over here. So there was some structural changes more than this deceptive smoke and mirrors thing. Look over here and don't observe what I did to the rest of the plans. That I removed the BMA. That's late. There we go. That one is August 22nd of 1979 drawings, and it's submitted as saying change of column type. Again, BMA's removed. It's not just change of column type. Extension of the kitchen area. Also, the reinforcement over here changes by a couple of pieces. So by them saying that, oh, we don't know what's going on, it's the planter boxes, it's the guy that put the plants in, we can't figure a thing out, but we're following that ACI code. We got an expert on board that's following the ACI code, but he can't see that this took place. This is what they present to us. They can't see that the elevation change took place. That's also what changed. The elevation of the deck change. That this does not meet rectangular array. I'll also make a mistake of saying triangular array because I see this and my brain just wants to default to that. That this is clearly marked as 6 feet in another drawing. This indicating from here to here is literally marked as 6 feet in another one of his drawings. And so he's clearly showing also where exactly it should be, right there. He understands that that's where it should be. And then showing how much is offset by. Same thing with this one. I circle that center part there. I'll remove it. Same thing with this, showing the offsets. Making it clear that the engineer knew, or architect knew, how much he's deviating offsets. This is a small offset there. That the engineer and architect knew exactly how much they were offsetting everything by. But, ooh, that's huge there. And this one's still in bounds. This one is right in bounds for not being out of bounds. But this is out of bounds considering the four together. This is all one deck. All right, it's not multiple decks. You know, that's still connected. The behavior that we know during the collapse literally is one deck with the separation of this expansion joint over here, of this control joint, that it behaved as one deck over to there, even weakening the structure. All right, I want to say have a good day. I just trolled myself doing this video, so give me a thumbs up, please. And again, they suck. And so we give a shout out to Sarah Blakely for, if you guys pay for the audio. Pay for the audio if you really must know the audio, and she has it of the property manager stating that he would walk the deck daily, and then he changed it to backtrack to change it to almost daily. And this is when he observed the fracture here many days before. Got hold of the engineering firm immediately, but they didn't come out immediately. It wasn't until the 20th. We see the image on the 21st. But that's the same time he inspected the roof for the anchors that they required there. That's as I understand it, per the paid, mind you, audio. It was a good audio. She dropped the ball on a few questions, but she did, you know, with her skill, with her knowledge. I mean, I think she did pretty good there. Based on Nist. Now, if she would do the one now saying Nist is full of shit, oh my gosh, I would subscribe to her then if she said Nist is full of shit. Any news station that says Nist is full of shit, I'm subscribing to them. Whichever one they are. If they got a subscription fee, I'll pay for it. Any news station that calls them out, I'm on board. And especially I'll be doing a video saying how they call him full of shit. All right, that's Georgie leading his loving. And I'm going to go take a break myself. Time is just being eaten up by this building. I hear you, George. That's George. All right, lovey. Come here. Good boy. Okay, you guys might want to see him. Hold on. Let's see if we can do that. Hey, George. Hold on. Do a shout out, Georgie. Nope, he's going to do a rub out. That means he's headbutting me. There we go. All right, take care, guys. I got to give him some loving. Bye.